Hello and welcome. Friday afternoon, last slot, so very happy to have you all on board. In this hackathon, we'll explore the world of tools typically used by hackers and how developers can leverage them to fortify their code and to detect vulnerabilities before they surface production environments. So today we are about to get our hands dirty, so I won't spend much time in PowerPoint slides today, but rather dive right in. Before that, let me quickly introduce myself. My name is Tobit. I studied in Bochum at Ruhr University. Some might know this one. I worked as a pen tester for a few years at SecConsult, and then switched this year to About You as an application security engineer. I'm also a coffee nerd, a dog person, and the world's worst DJ, which both me and my girlfriend can say so. So now that you know about me, let's see what we are going to talk about today. So as you might have seen already, there's this QR code over there. If you want to follow along today, you don't have to. You can just watch me do all the hard stuff. But if you want to, you can definitely follow along. If you just scan the QR code, there will be a GitHub gist, and you can download all the tools if you want to, and follow along. All the tools are open source or free to use. So yeah, no problem with that. And also, I will do a quick introduction so you have time to download everything. So, as I said, I will start with a very short introduction. I will keep it on the short side here. I will give a brief overview of the tools of the trade. So, which tools are going to be used today, and then I will discuss how those tools can be used for defense, because typically hacker tools we imagine like tools for attack. Then comes the part why you're probably here. So that's the part with the live hacking and demo. I will present the target, what we are going to attack today, and then I'll go into the live hacking. I show different tools, how to use them, and I will list also some alternatives. Finally, I will finish off with a short conclusion or a recap, and then we have time for some questions, I hope. Okay. Let me set the scene here for a second. So as we all know, probably the cybersecurity landscape is always evolving. There's like always the next big shit out there, and it's really hard to ride the wave, as we just heard in the panel. And so it's important to stay ahead of potential attackers because they never sleep. They all have all the time at hand. And I really do believe in empowerment through knowledge. So I want to emphasize that understanding these tools can make you a better developer, just because it can give you a competitive edge above others. Just because you know those things, you can find your own vulnerabilities earlier in the process. And as we heard yesterday, this can have a rather big impact. So yesterday we had a figure of like 600 times more cost in a late found vulnerability. So that's quite an argument for that. We're about to flip the script for that, so we see how these tools can be used defensively, as I said, and also I want to point out that actually there's a pretty common goal for both hackers and developers. Both want to find vulnerabilities, they just have divergent intentions, of course. So it's only natural that they also use the same tools, I think. Let's get to the heart of the presentation, the tools to find, used to find vulnerabilities. So before I look into that, just a quick shout out or a quick disclaimer here. Of course, there's no tool ever that fixes all your vulnerabilities. There's not even a tool that can find all the vulnerabilities, of course. There's no magic bullet. So they are just, as the name implies, they're just tools to help you. But in the end, it's the person in front of the screen that does the heavy lifting and identify all the vulnerabilities. So let's get everybody on the same page with some of the terms and types of tools I'm about to use. I will give, as I said, a short introduction. I don't annoy you too much. And also, the tools I'm about to show you, I try to categorize them a little bit, but most of them don't really fit in one category, so don't be too judgy on that one. Many of those tools can be used for many different things, but that's outside of the scope for today. Starting off with useful tools, this might be obvious, but yeah, this is everything that helps you achieve your goals, and a very big one for me at least is Python here, because I had like countless occasions where I just needed to quickly do something to like convert something from A to B, or just change something of just a little bit, because all the tools I was using didn't offer this option, and something like Python is very, very useful for that, as you already know. Of course, every other programming language also works for that if you're comfortable with that. Yeah, Burpsuit, it's like the jack of all trades. It can do quite a lot, so it's useful for many, many different things, and we will spend quite a lot of time there. And also encoders and decoders, like CyberChef, for example, are a great example of useful tools that can be used like for a wide variety of different topics. Then we have the classics, port scanners. So most of you probably have heard about Nmap. It's the de facto industry standard. It's used to find open ports, services, and also active machines. But we have also alternatives, as I said, like Marscan, for example, which is like more scripted to be used for many, many targets. So if you have like very, very huge IP ranges, many different targets you want to attack, Marscan might be the choice for you. And also Nabu is quite new, from the project discovery team. It's on GitHub, and it's more designed to work with other tools from project discovery, so they can go hand in hand. So you can, for example, find open services and then scan the services directly with one step. And so they do the same thing, basically. They should find all the same services, for example, but they have different strengths. Then talking about fuzzers, there are different kind of fuzzers. So some of you might know AFL++ or AFL, the previous version of it. That is a fuzzer that is used to find like memory-related bugs in mostly C and C++. We're not going to talk about this today. So even though this is also a fuzzer, we are more likely to talk about, or we are going to talk about web fuzzers, of course. Fuff is a great example for that. So it's written in Go. It's super fast, and you can also do like find routes, you can find virtual hosts, stuff like that. So it's also a very useful tool. Unfortunately, not really in the scope of today, but I highly recommend it to have a look at that. What we'll look at today is SQLmap, and it's also very widely known. It's a tool to automate the detection and exploitation of SQL injection vulnerabilities, and yeah, it's known for a very long time now. Also, we will look at vulnerability scanners, which try to just find publicly known vulnerabilities in software, mostly outdated software. And here we have examples for like Nessus, which is an enterprise-level scanner that can handle a huge amount of targets. It's very huge, but like enterprise implies, it's a little bigger, and it's not that easy to start just quickly scanning. For that, Nuclei is well more suited. So it's open source. It's a template-based scanner, and what that means I will show later off, because I will demonstrate it and show how easy it is to use. And of course, there's Metasploit, a prime example of a tool that fits in multiple categories, I think, because again, like Burpsuit, it can do many different things, and it's, for example, used for scanning and exploitation. And finally, we have code analysis tools, which especially for developers are very interesting, because you are working with source code. As a hacker, as a former pen tester especially, I didn't have the chance often to get the source code, so code analysis wasn't that big of a part. But I was working as an application security engineer. Now it's very easy, and it's really good. For example, Spectral is used to detect sensitive data, like API endpoints, credentials, private keys, so all the sensitive data you don't want to publish in like public repositories or public packages. Then we have Zemgrep, which is an open source static source code scanner, which just generally finds vulnerabilities in many different kinds of vulnerability in programming languages and frameworks. And finally, we have SonarQube, which, similar to Nessus, is like the enterprise-ready version of it, which really concentrates on integrating in your environment, like CI/CD, GitLab pipelines, stuff like that. But again, these tools are just tools. They are neither good nor bad, and they can also be used by defenders and not only by the hackers. So let's have a look at that. For example, using reconnaissance tools, we can use reconnaissance tools like Nmap to find potential vulnerabilities very early on in the stage. Imagine I'm deploying a new service or a new application, and the first thing as a developer, I should think about, okay, I have deployed to a system, maybe there are some older versions running on it, or there are some other applications running on the same instances. Especially in older environments, this is often the case. So using Nmap to find other services is very useful. However, using all these tools won't make a proper pen test, a proper security analysis obsolete. So you definitely can't skip this if you just like started Burp Suite once, clicked through it a little bit, and then just said, okay, yeah, I found all the vulnerabilities. Let's be done with it. So using tools like, for example, Zemgrab, finding vulnerabilities in the source code won't make this obsolete, unfortunately, but it will catch most of the low-hanging fruits, which is a very, very good thing, I think. Okay, with that out of the way, as promised, a very short introduction. Let's speak about the target. So the scenario I wanted to paint here is I am a software developer. I'm not, so please don't go too far into details. But the idea is I'm a software developer, and I created this new application. It's called Securant. And for me, it's securant.shop, but don't be confused. You'll see soon why. And it will look like this. And as I said, this is supposed to be a practical workshop. So I won't annoy you with PowerPoint anymore. And I will quickly open the shop and show you it live. Okay, so you should be able to see my screen. Perfect. Oop. This one. Okay, so we have securant.shop. All of you have seen an online shop, so I won't annoy you too much with this one. It's like the regular online shop. We have products in here, like a fancy hat or a hoodie, now with even more hood, apparently. So we have reviews. Everything we would expect from a normal online shop we have here. We have login center, all of that. So that's good. And as I said, it's securant.shop. But if you want to follow along, you can totally do, because I also have an online version of that, which is securant.link. It's a different one. And you can follow along, download the tools, or use the tools that I'm presenting and do the same stuff that I do if you want to, and do it on the online version. I will do it the local version because if for some reason you break the online version, then the talk isn't over and I can continue. So that's basically the idea. Okay, let me quickly show you the, let me do the extended screen for a second, and I will show you the QR code for it, just in case you want to go over that. So this is the QR code and the link for it, and I will give you like a second if you want to follow along and open the link. Okay, I think everyone that wants to follow had the chance, so let's continue. I'm doing some switching around here, so excuse that. So as I said, the first thing I would like to do is I deployed the application, or at least that's the scenario. And the first thing I would like to do is to see if there are other services running on the instance. So I will open my terminal. And the first thing, as I said, doing some port scanning. And as Nmap is the de facto industry standard here, I will also use Nmap here. And the by the way, is this readable from the behind? Perfect, very good. Okay, so I will scan the online version for this example, because scanning my local version is not that not that easy, or not that representative, so to say. So I will start by just typing nmap to start it. I will give it the -v flag just to be a little bit more verbose, just to have a little bit more insight, because otherwise nmap will run for some time and we have no output, and yeah, a little bit verbosity doesn't hurt. I will also give it a second flag, which is top ports. And I will give it the top ports of 1000. So that doesn't mean like the ports from like 1 to 1000, but like the 1000 most used ports. And I'm going to do this just to increase the speed a little bit. I know which ports are open, and I know that it doesn't bring any value if we wait like 10 minutes longer for this to finish. So yeah, I will use the host name, the online host name for that, and we'll start right away. And as we can see, nmap starts and finds some open ports here. So we have, for example, port 443, which is TLS, as pretty much every one of you should know. We have port 80, also HTTP, but we also have port 22 open, which is SSH. And this might be the first clue that you might want to have a look at your configuration of your instance, for example, your AMI, whatever you're using, because especially if this is a production environment, you obviously don't want SSH directly enabled on your machine, because if for some reason or the other your private key, your credentials, or whatever are leaked, or they are brute forced, if you have password authentication enabled and no fail to ban, then yeah, you might have a bad time, and you definitely want to disable this. So very, very easy. It took like, I don't know, like 20 seconds this run, and we discovered something that might slip through the gaps, and we could just simply avoid it by just disabling SSH, or just changing the firewall, changing the security group, or whatever you're using. So. But nmap can do a little bit more. So nmap has an inbuilt scripting engine, and it's quite powerful. You can customize it quite a lot. But for our scope today, it's not needed. Actually, we can just add the -A flag here, and it will just include every script it has, everything that is secure at least. So it also has like insecure scripts, but it won't include them if you don't force it. So we just add the -A flag, and what it will do is it will do the same port scan again, because it doesn't cache the result, unfortunately, but it will do the same scan again. But afterwards, it won't just finish, but it will do a scan for every service found, and it will show some information about the service. So this is highly dependent on the service found, for example. So for instance, if there's SSH found, there will be different scripts running than for HTTP, of course. And yeah, and if there, for example, is FTP enabled, then this might be as good as like listing the files within the FTP server if it's enabled with anonymous authentication. So it can do quite a lot here. We can see the ports are found as open again, and now the scripting engine started, and it shouldn't take too long before we get the results here. And we already finished. So with one service and with yeah, that little services open, it's very easy. And we can see here, for instance, the SSH host key. This is not a vulnerability, of course. This is just a fingerprint of it, but it's like further information that might be useful, not for us as a developer, but it's nice to have. Same or similar for HTTP. So we have some methods that are allowed. Okay, thank you. But interestingly enough, for HTTPS or SSL HTTP, we have some interesting stuff, which are those two lines here. So I assume most of you know the robots.txt. Just in case, I will quickly mention it. So in the robots.txt file, it's in the root file of your web server. Then there you can specify entries, so the Google crawler or any search engine crawler won't index your pages if you don't allow it explicitly. So, and the script from nmap parses this robots.txt, for instance, and here we have the /ftp folder found, which might indicate that, yeah, this might be something interesting to look at, and indeed we will look at this later on a little bit. Okay, so with that out of the way, we're not really into networking today, so I will close the network scanning part for today, and we will rather have a look at the application itself and what we can do there. Coming from a consultancy, it's very natural to me to do the next thing, which is open Burp Suite. I have already opened a project here, and this is Burp Suite Professional. I gave you the link for the community version because everything I'm going to do today you can also do with the community version. The professional version can do a lot more things, so I can highly recommend to buy a license if you want to play around with it, if you like it. But for today, you don't need a professional license. And upon opening, maybe just a quick sleight of hand. Who of you have used Burp Suite before? Okay, cool. Quite a few. So if you open it on the first time, you can see, okay, there are quite a few buttons and quite a few windows, but it's actually pretty simple. So the first thing we can do is we go to the target tab because we want to specify our target. And as I said, especially as a pen tester, it was very, very important that you always select your target so that simply you don't attack applications and services you're not supposed to. And in here, you can go in the scope settings and add your target you want to add. For me, this is going to be securant.shop. And I will also specify the port. We don't really need this, but for today I will do this. And that's it. So now that we have our target selected, every instance or every attack, every action we're going to do within Burp Suite will be limited to this target. So it won't scan other domains, other services, stuff like that. The next thing we're going to do is going to the proxy tab, because Burp Suite at the heart is just a web proxy. So requests from the browser are proxied via Burp Suite to the server and back. And the powerful thing here is we can intercept those requests, we can change them, we can repeat them, we can delete them if we don't want them. So we have very much freedom here. And we can configure our browser to use Burp Suite as a proxy, but we can also just open another browser, which is pre-configured with Burp Suite, and that's way easier, and this is what I'm going to use today. So let me quickly open securant.shop, our target application again, so nothing new here. Let me see if I'm still logged in from my test before, so let me quickly log out again. Everything the same as before. However, if we jump back to Burp Suite now and look at the HTTP history, we can see that, and if you would have checked it before, it would obviously be empty, but now we can see there are some requests coming in. So this is the list of all the requests coming in and out of the system. And for instance, if we go back to the dashboard, we can already see stuff is populating, and Burp Suite is accumulating all the data and collecting it for us. Same for the target tab. If we look here, we can see on the left side, there's a tree with all the files and all the routes. And in the middle, there are the requests again. So from just this one load of the page, we have lots and lots of information, and we can already start digesting this. So for example, on the right side, you should be able to see my pointer. Yeah. So from the right side, we can see there are issues listed here. And here, all the vulnerabilities that Burp Suite on its own was able to find will be listed. And if we go over it, we can see, for instance, that we have this cookie without HTTP only flag set, which is a very, very common finding, obviously, for web applications. And without doing anything at all, Burp Suite found it just because it saw the request. We can have a look at the request. Let me just make this a little bit bigger. We can have a look at the request that triggered this. And the response there is highlighted where the token was found, where the token was sent by the server. And indeed, there's no HTTP only flag here. So this is the first thing we can improve. This is the first finding. It's a very low one, obviously, but we can directly do this. And it's making it very easy to find those things. OK, so again, looking at the proxy tab quickly, we can see that there are different colors here. So Burp Suite automatically highlights all the requests which contain a JWT, so a JSON Web Token, which is quite interesting because these requests are often authenticated or they are connected to a session somehow. So that's useful to know. But for now, I don't know if you like me, but you can see those requests, and those are all JavaScript requests. I don't really like them because they just clutter my view. I don't really need them. So I will just use this gray box above here. If you click on it, then you can hide JavaScript, for example. And I will also add WoW and WoW2 here because we also don't need those. And if we apply, we can see that the HTTP proxy will be updated and those requests won't be shown anymore. That doesn't mean like ignore JavaScript in general. It just means like for today, we don't really need this. We don't go into that much detail. And just to give us a little bit more breathing room, I will exclude those. OK, great. So with that out of the way, we can start clicking around in the, let me actually make sure, yeah, OK, I have the right browser. With that out of the way, we can click around in the application and just start seeing what Burp Suite does. And I think it's very good to see if we just make a split screen out of it, because then we can see if we click on a product, for example, there are those requests coming in. Or if we, I don't know, maybe click on login, we can see there's the next request coming in. And now the next very powerful thing Burp Suite can do, as I said, it can intercept, but it can also, let me quickly try like some gibberish here. We can go to the proxy, and instead of the HTTP history, we can use the intercept tab, which does exactly what the name implies. It's intercepting request. And if I enable it, and I will click the login request, OK, the first request coming in here is like not the login request itself. There are some requests coming in and out all the time. I will just forward this one. Same for this one. But now we have the post request. Oh, actually, it's not the right one. Sorry, there are quite a few coming in. Let me skip over all of them. I shouldn't have. Have I clicked on login? No, I haven't. OK, that might help. OK, so now we have this login request here. And the good thing about that is we can change it. So for example, let me just type something else here. And we can just forward it and then stop intercepting. And if we switch back to the history then, to the latest request, which is this one, and we can see it has been edited. So we have an original request, which was test@test.com. And then right here, we can switch over to edited request, and then we can see the gibberish I entered, basically. And we can do this to do interesting stuff. For instance, the first thing I would like to test, because the last thing apparently I implemented was the login form. And my idea was a user shouldn't be allowed to log in with an empty password. It just shouldn't work. And he shouldn't also be able to register with an empty password, because we want our users to have safe passwords, right? So since we don't have a username right now, let's quickly create a new user, something like user1@test.com. It doesn't really matter. Now I want to use an empty password just to test if my checks were successful, if my mitigations were successful, so that a user can't log in with an empty password. So I will leave this empty. I will select some security question, doesn't matter. And as we can see, it doesn't work, of course, because it's not validated. We can't click register right now. But we could now start fiddling around with HTML and enabling disabled user fields and buttons and changing classes, all of that. But I don't know how you are, but I really hate this. So what I will do is just enter something in here. And I probably haven't typed the same thing. Oh, yeah, it's not long enough. Let's do it as well. And I will intercept the login request or the register request. And what I can do now is in the password field, I can simply remove the content. So bypassing the client-side validation completely, I will just drop this. I will forward this request. And now we can have a look here. And it's about to say, OK, invalid email and password cannot be empty. So apparently it hasn't worked. But we should try this, because just because the application says so doesn't mean it doesn't work or something. So let's see with user1@test.com, and shoot, we have to enter a password again. So same thing again. Enter the intercept node, log in, remove the password, forward it, and that's it. So as we can see, the validation was only client-side. The server didn't care really about what we did client-side. And we can log in with an empty password, which, of course, is a very rough example here. It's not very realistic. I mean, most of the users won't open up Burp Suite to remove their password, because it's just like not a regular use case. But it really shows very well, I think, how easily bypassable client-side validation is. So with that, it's very easy. And as a developer, it's very easy to debug this. Yes, so now we're logged in. And what we can do now, for example, is this crazy hat. I really need this one, so I will add this to my basket. And maybe I will also add these gloves. I don't know. And then let's go to my basket. And as we expect, there are my items. So that works. Let's go to the HTTP history here for a second. And as you can see, all the requests went blue because we have a new session. We are logged in now. So we are in an authenticated session. And for instance, we can look at these requests over here, which is, I don't know if you can read this. Yeah, you should be, which is a request to a REST API, basket, and then the 6th ID. And this makes sense because when we log in, we will get a token. Let me quickly make this bigger, just so it's easier to see. We will get a token, and we also get a basket ID for the current user. So my basket ID for the current user is 6, and if I open my basket, obviously I will see that it's requesting the basket ID with the ID 6. So the next thing I can do is repeating requests that I've already done. So if I right-click on any request, I can send or select the send to repeater option. And handily, the repeater blinks for us, so we know that something went there. And if we just click on send, the same request will repeat it as often as we like. So we can do something like, okay, we quickly have to repeat something like 20 times. It's very easy to do. If we have to do something like we want to repeat something 2,000 times, which also happens, then we can use the intruder for that. We won't we won't test this today because the intruder is very limited in the community edition, and yeah, so I will stay with the free stuff for today. So what we can see now is the data for my user, and which is in the basket. So we should see the hat in here, and we see the gloves. What we also might test is what happens. I mean, we saw client-side validation. What happens if we request other stuff? So if you just change the basket ID, for example. So if I add or change the basket ID to 7, it says success, which is frightening, but there's no data appended to it, which makes sense because I was the last user that has registered to the application, so 6 should probably be the biggest ID available. So let's go back in time and use the basket with the ID 5. And as we can see now, we have data, and that's not the data I have added to my basket. So indeed, this is the basket of another person, and we can also change the request again for 4 and 3, and for all of them we get data. So yeah, simple as that. We find the next vulnerability in the list here, and we can easily do this and test this out with Burp Suite just because we can change every aspect of the request. For example, if we wanted to test something, it doesn't make really much sense here, but we could do if we wanted to. We could add a second cookie header here, which try to do this in your natural programming language. Add 2 cookie headers. Most of them will like throw error messages or stuff like that because it's like not intended to do this. Burp Suite doesn't care about this, so it's just sending the request raw, And you can also remove headers if you don't like them, if you don't need them, stuff like that. So that's very handy. With burp, you can also change like the HTTP type, so from HTTP 1.1 up here to 1.0, but you can also change it to X, Y, Z, for example. So just throw in some gibberish and see how your application reacts. So you can really play around and do crazy stuff with it and see how your application reacts and just find your way around. And since we worked in burp suite all the time, the target tab will expand and will collect all the new information. So if we go and expand branch here, we can see there's quite a lot of data just from this, I don't know, like 5 to 10 minutes of scrolling that has been added here, and we can go back to every request here and see how it did. So what we also can do, which is something that's very useful, it's not useful most of the time to find vulnerabilities, but just it's a quality of life feature. If you go to the proxy settings, there are quite a few settings. I won't go over all of them, of course, but we can use match and replace rules. So for instance, something that I'm always annoyed of are those two. And that's caching, of course, because with every request, I want the fresh results from the server, and I please don't want a cached response with saying, okay, yeah, not modified. Yeah, I can't work with this, so I changed it like this. And there should be some requests in here, like this one or this one, that are a HTTP 304 not modified. And if I quickly reload the page, all of them should get fresh results now. Just like that, because if I open the proxy settings again, all it's doing is it sees for every response coming in, it searches for this request header, and if it's present, then it will replace it with nothing. So it will just remove the header from the response and from the request as well. So we have no caching here. And you can also do this with all of the other stuff. So for instance, if you are getting like a cookie every time from your server, but you want to force a specific cookie and you always want to use the same cookie, just use a match and replace rule here, and you can hard code the response from the server, even though the server sends something completely different, and just enter like if a new cookie header, then just send this cookie, something like that. So also very, very handy. Okay, I could hold like 2 more talks just about burp suite. I won't do this today because we have some more tools to cover today. But if you take just one thing away from this talk today, burp suite is great, and start using it. I would highly recommend this. Okay, so the next thing I would like to look at, ironically, I will spend just 1 more second in burp suite for that, is I will go back and search for this request, which is the login request. Also, very handily, it's highlighted for us, and I will send it to the repeater again. You can use shortcuts heavily in burp suite as well, so Command R and Control R, whatever you are working with. And let me quickly rename this tab. So this is the login request, and we can also do this again. Oh yeah, okay, the test's still in there, so that doesn't work. If we log in, we get a fresh token, and for example, if we want a new token every time, we can just repeat this over and over again, and should get a new token every time. What we also can test here is validation, as I said, but not client-side validation, but server-side validation. So for instance, let's just add another quote in there. I should be able to see it. And as we can see here, I will make it a little bit bigger again. We get a nice big error message, nothing nice to look at. And we can see, okay, we see some SQL query in there. And as most of you have probably already guessed, if there's SQL in this response, something is not right, and it's probably time for SQL map. So what we can do now is we can use burp suite to highlight everything from the request and copy it to a file. Let's just call it like login.request or something, doesn't really matter. And then I will go back to the terminal where our request is located now. And what we can do now is use SQL map. As I said, it can be used for detection and exploitation of SQL injection vulnerabilities. And since we found SQL in the response, there's quite the chance that there might be something up. So let's use SQL map. And using the -r flag, we can load a login request, or just any request, to be honest. So we can just use any request at all, and we don't have to fill in any other data because all the data has been filled in by burp suite for us, and we don't really have to do anything else. And if I just start SQL map now, it will run away, and it will start asking me questions. So every time SQL map does something where a decision is involved, it will ask you. So that's very handy. And in this case, it's asking me, okay, there's JSON data found in the post body, which makes sense, of course. Our body was JSON in the first place. And it's asking if it should process it and if it should work with this one, basically. Yes, please. Oh, 1 second. So since I did this before as a test, SQL map stores request, unlike nmap, so there was the finished exploitation already finished. So with the -- flush session, we can remove all the old data. I will leave it in for now, just so that we can see the whole request and not directly jump to the solution. That would be a little bit boring. So let me do this again. Again, SQL map asks for the confirmation. We can just hit enter if we want the default thing, and most of the time, the default option is the best option. So you can change it around a little bit, of course, if you know what you're doing. But yeah. OK, so we saw an SQL error message in the response in burp suite. But now SQL map says, OK, no heuristics have shown that the parameter email might not be injectable. So what can we do? Read the error message, basically. So this is a very good example that literally everybody can use these tools if they just read it. Because what it's saying here is try to provide the right authentication type and valid credentials. 401. So it's talking about there is a HTTP 401 request or response coming in, and this is weird. So if this is intended, though, try to rerun by providing a valid value for option -- ignore code. And if we look back in burp suite, and I will add an empty request now, so without any, that's the correct one, that doesn't work, of course. So we send any wrong data, then we get an HTTP of 401. So that is expected. So SQL map won't guess the right password and username combination with the first try, so it's expected that it's unauthorized. So what we can do now is read the text and just do exactly what's saying it. So ignore code 401, saying to SQL map, OK, please ignore 401s, they are expected. Do this again, and I will continue. And in this case, it's saying it's not stable. I will continue anyway. And ta-da, it already says, OK, now it's working, and it appears to be end Boolean-based blind injectable. It looks like the backend DBMS is SQLite, which is fitting with the error message we were getting earlier. And so I will just continue. And also, it's asking if it should extend the provided level just to do more tests to analyze the vulnerability even more. I will also do that. And then we wait a second. And then the next question comes. And I will give a little tip about this very soon. So it's asking if it should only put basic union tests in there if there's no union injection found earlier. So it's basically asking, shall I reduce my tests if I don't find something valid, basically? And we say yes. And now it's saying me, oh, it doesn't seem to be injectable anyway. So this heuristic might have been wrong. So it looked like an SQL injection, but it actually isn't. So this might be the end of the story. But again, as I said, just read the next text and just continue with it. So SQL map is suggesting try to increase value for level and risk options if you wish to perform more tests. And since we saw in the request, you can also always go back in time for all the requests you did. You can just go back over here. But as this is an SQLite error, and there's virtually no places where if you see such an error message that there's nothing to get there. So we are pretty sure, okay, there has to be something. So all we are going to do is just increase the level and risk score. And the level score is basically saying, like, in how many places and how many different tests is SQLmap going to perform. So if it's usually running on level 1, but we can crank it up to, for example, level 3. There are 5 levels, just increase it a little bit more. And for risk, we can use risk 3 as well. This is the maximum risk, but since this is a local version and not a productive environment, I'm willing to take the risk to break my own system. I worked for multiple years as a pen tester. I never broke a system with risk 3, so don't take my word for it. Don't quote me on that one, but the risk score is a little bit overhyped, I think. What I also will add is the --batch flag, which is saying, hey, all the requests you're asking me, don't bother, just do the standard stuff. Just do the thing you think is fitting the best. So now it's not asking me, but it's always choosing the default question and the default answer. And just like that, we found an injection. Actually, we found 2 different types of injections. We found a Boolean-based blind injection, which is basically saying something like, if the first character of the first username is equal to A, then do something. Or if it's equal to B, then do something else. And like this, we can have a deduction of like what is the username in the end. And we also have a time-based blind injection. So this is with including time. So for example, if the first letter of the username is an X, for example, so the only names Xavier I'm coming up now, is then we can say, okay, server, please wait for 10 seconds. And we are testing new characters. And as soon as the server starts to sleep for 10 seconds, we know we have the right character. Okay, so we have found 2 vulnerabilities now. 2 SQL, well, this is one SQL injection with 2 different exploitation types here. But so far, we only spent like time in the terminal, and it's like very theoretically, so to say. I mean, of course, we're doing this by hand, but this is not very nice to show to your customer, to your developers, and it's like a little boring just to say, yeah, there's an injection, and here, look, there are like 10 lines of code to prove this. What we're going to do then next is we can play a little bit around and see what we can find in the database. So for that, the first thing I'm going to do is I will add another flag, which is --tables, and I will remove the flush session now, because now it's very handy that SQLmap is caching my found vulnerabilities, because like that we don't have to find the vulnerability over and over again, but just use the already found one. So if I do this, we can see SQLmap is running away, and it's using this type, or the type of injection that is the fastest. And in this time-based is very slow, so we're using the Boolean-based blind injection type. And if I scroll up a little bit, it's saying it's running in single thread mode. That's okay for now. And it's trying to enumerate all tables of the SQLite master database. And then here, I think you were able to see it. It ran very quickly, but all the characters of the tables went in one after the other. So it wasn't like that the first whole word came in. This is because we have to test each character on its own. But as you have seen, it's pretty fast. So overall, it doesn't really hurt. OK, now we have all the tables. And one of you, or all of you, might have a quick guess what is the first table we're going to have a look at. Of course, the users database, the users table, sure. So instead of enumerating all the tables, let's choose the users table, and we can either dump the whole table right away, or we can show all the columns in the table. I will do this again just to show you like the characters all coming in, but I mean, you have seen it now. It's not that interesting to see characters flying in the terminal, so I will stop this. And instead of columns, I will get all data, which can be done like with just the dump flag here. Okay, so as we can see, it's rather slow for a huge amount of text. So we remind ourselves, okay, we have this single-threaded thing. Let's change this. So this is slow. We want it a little bit faster, so we can add another threads flag here. And for the local version, I'm going to use 10. I don't know if you are following along in the online version. If you're doing this on the online version, please skip this step for me, because otherwise, yeah, this whole environment is a little dodgy. So it should come back online automatically if you would brick it, but it might take like 10 minutes. And so please skip this step, because it generates quite a lot of traffic. But for the local version, it really doesn't matter. And as you can see now, the multiple threads are really working for us here, and all the data is coming in. So as I said, waiting for characters to fly in the screen is pretty boring. So I will go to the next step, and I will come back once this is finished. So opening a new window here. Let me quickly clear the screen. I would like to show you the next tool, which is also very easy to use, uses way less flags, and it just gives you quick wins, which is Nuclei. I really like Nuclei. It's a open source tool with a very, very active community right now. And the idea behind Nuclei is that we have templates, and the template could look like, for example, with the robots.txt, if you remember, a template could look like, do a request where you request the /robots.txt endpoint, and if data is coming back, then report it as we found a robots.txt. So this is a very simple example, but you can do this arbitrarily complicated as well. So for instance, if you have an outdated Confluence application, and there's this one special endpoint which is only valid for this one version, and it's only, you don't get like sensitive data, but only in this one version, the Confluence responds with this specific error code or with this something, then you know definitely this is a Confluence in this version. And there are like thousands of templates out there, and you just run Nuclei against the web page, and it's terrifying how much it can find, just because all the templates are coming in all the time. I will, oh, it's probably a little bit small now. Let's zoom in a little bit. So for Nuclei, what we can do is simply use the URL for that, which is securint.shop. Remember, securint.link for you, of course. And we'll fire away. And what it will do is, the first thing is, it will download the latest templates. As I said, they are a very active community, so it's very common that you have to download quite a few of them. And also, the Nuclei version itself is always outdated, because they are pushing out new versions all the time. So, but that's nothing to worry about. The version runs as well. So let's have a look at the results. We can see, for example, the HTTP missing security header findings here. That is very, very easy. So you just create a template that checks, does the response includes, like, for example, the referrer policy header? And if not, create a finding out of it. Those are not really the interesting parts. This is not the stuff. This is not #1 priority for most of us, I think. So we can skip over this. And most of the templates are going to be informational findings, just for you to know. And this is also often used by pen testers, by attackers, just to learn about the environment, what's going on there, what's happening there. And for that, it's pretty useful. But it's also finding different stuff. For instance, we have this /metrics endpoint. Let me quickly open this one. And yeah, so since this is a known endpoint, we have some metrics that are exposed here. Also, to be honest, I haven't really looked over it, because I knew that's existing and stuff like that. But usually the metrics are not like that critical, but it's just nice to know, and it's very easy to find. It's just one request. It took 15 seconds, 20 seconds maybe, and you can find such findings and just disable this. Going on and going further, we can see, we find a Swagger JSON, and hey, that's interesting. Just by scrolling through the application, we haven't found like a B2B API, but since /API-doc/swagger.json is a very well-known path as well, Nuclei is able to find it. And yeah, I don't think we have time for today, but obviously you would be able to find some more stuff there as well. So it's very easy, and it's very good at finding the low-hanging fruits and all of that. Okay, so Nuclei is finished. So for this example, there are no crazy findings. This is like not a zero-click RCE, stuff like that. So nothing of the real super fancy shit. But this is the type of vulnerability that would still be or would be found in a pen testing report. And to just finish all of these stuff up right away, just do it directly, because a pen tester will report this, and so you can fix it right away. And those are all not big findings and just easily fixable. Okay, so with that out of the way, we can have a look back, and we can see SQL map has finished running in the background. And I don't know about you, but this is not very readable. So let's look at the CSV itself. So let's see. It's under the dump, and then the name of the database, and then it's the users table. And I will only I won't open all the fields, because then it's the same view again. I will I think like the first field should be enough, I think. Yeah, okay. Okay, so looking at the results, we can see we have some the IDs, we have the roles, we have emails, we have the passwords, which are hashed, but also for some reason we have passwords in clear text behind the hashes. So this one empty. This is weird. This is my password. Why is this in the database? This should be hashed. I mean, some of you might already seen that this is not like a very good hashing algorithm. The length and the format of the hash implies that this is an MD5. So overall, not a very good hash anyway. But why are there clear text passwords in here? Because for other users there aren't. And if we scroll up a little bit, we can see that SQL map is able to brute force most of the hashes. Or not most of them, but it can find like many different hashes out of the box. So you don't have to install another password cracker, just another tool. You can simply let SQL map do its thing, and we can see that 4 hashes, I think, 4 hashes, we're able to be cracked, and we can probably use those to log in into the application. Great. Who used threads -100? Stuff like that. Okay. Yeah, it should come up like in about 10 minutes, I think. From experience, I can say. Sorry to say, but this is why I use the local version. Nice. Okay. Going over the next part is the source code scanning. So let's see. We have one of those. Yeah, this one should be in here. We can go over. Okay, we can go through the repository, and we can. I would like to demonstrate how easy it is to find many different vulnerabilities in the source code if you have it. So for that, I'm going to use zemgrep. Zemgrep is, as I said, a static source code scanner, and I can quickly scan the repository I'm in. So, sorry, I haven't showed you. This is the repository of the application itself, where I simply did npm start. So it's running from here, in another terminal, of course, but it's running from here. And all I'm going to do now is do zemgrep -- config with auto. And zemgrep has many different configs out of the box. And yeah, we can quickly scan it like this, and wait for the results coming in. Okay, so we have quite a few findings there, and 60 findings in 700 files. I won't go over all of them, obviously. And as this application is meant to be vulnerable, it's obvious that there are quite a few findings. But for instance, let's look in the results and see what we can find. And let's have a look at this one, for instance. So what it's saying here, that there was an eval detected. So evaluation, and eval is, as I hopefully everybody of you knows, can be quite a dangerous function. And it's found in the routes user profile .typescript file. And we might have to look at this. So I will open my Visual Studio Code. Yesterday I've seen the Vim talk. I'm not that fluent in Vim that I can use all the tree browsing and stuff like this. So I will have to use an IDE or a browser like this. So okay, so I forgot where the file was. It's in routes and then user profile. So quickly go there. Okay, and then we can find the eval right here. And then we can see, okay, does this have the potential to be a vulnerability? So if we look at the code, again, maybe I will make it a little bit bigger for you to see. If we backtrack a little bit and see where this is coming from, so this code is coming from the username, where it is cutting off something, and the username itself is just the username provided by the user. So what it's doing is it's doing a regex match against this regex, and regex is a whole different topic. I won't cover it, but this is matching for a hashtag and then curly braces. So some of you might know this is a typical annotation for templating engines. So this is something to do with templating. So what we can do now is go back to our beloved burp suite and have a look at the request. But before that, let me quickly go back to the store or the shop itself, because we have to set the request in there. So I haven't gone over all of these functions. Feel free to use them and to check them out. There are quite a few nuggets there. So at the user page, we can see we have a username we can fill in, and we also have like an image URL. We have we can upload a picture, all the good stuff. But since we're talking about the username right now, we thought, okay, let's see all the preview there. We can enter some username, and if I just enter test, for example, and set the username, we can see our username is stored here. So no rocket science. Again, back to burp and have a look at the last requests. And it's the post request here. And we can see, okay, the username is test. So there's that. And what we can do now is, as we saw, okay, something is happening if we are entering templating or input that is formatted like a templating snippet. So let's simply do this with a hashtag and curly braces. And a very quick and easy way to test this would be to do something like, I don't know, 1 + 1. Just do anything at all that can be evaluated logically and see what happens. So, okay, our new username is not test anymore, and it's also not 1 + 1, but it's 2. So we can see, okay, some evaluation has happened there, and yeah, what can we do with this now? Because yeah, it's funny that you can set like you can remove the backslash from your username, great, but what can you actually do with this? So server-side template injection, which is the name of this vulnerability, is quite dangerous. It's like often overseen by many people, but it's a very, very powerful attack, and it always depends on the templating engine you're going to use, and also like the environment, how it's set up. But yeah, I won't go into too much detail for template injection today, just because this is not the scope for this. But just to demonstrate, like with SQL map in the end, I want to demonstrate like how bad this is. I will spare you all the annoying part in finding out what type of templating engine this is, what we can use there, and just use a function here, which is global process main module, and it's very small for me here. So So we are requiring a child process module here, and what we want to do with this, of course, is to execute stuff, because executing stuff is always fun. So let's use the exec function, and in there we can use, for instance, the ID parameter. So let me quickly copy everything and set the username. And well, it's really small. I can't read it myself. Let's see. Oh, I forgot the exec, I think. Okay, so now we have an object here. That's quite weird. So why is that not showing like the request we did? So we asked it to execute the ID command, but it's just showing an object. So that's happening quite often. We can also have a look at the post request here. So here it's setting the username, and here it's getting the profile. You can also search for, I don't know, like username in here, but it won't be in here. So it's really just set to the object. And this is a typical example of a blind vulnerability, what I just mentioned. So this is a vulnerability where you won't be able to see the result directly in the response, but you rather have to to expand on it, and you have to see what else you can do with this. And a very easy way to do this is to see, can the machine I'm working with execute stuff that is reaching something outside? So I will do something like for example, let's try a wget to HTTP, or not HTTPS, HTTP, localhost, and then some port. I haven't started a server yet, so let's quickly do this. I will use Python for that. As I said, Python is a very useful tool for many different reasons, and this is a very good example for this. So I will just simply use the python.m http.server on port 9000, and that's it. Now we have a web server, and this is why I really love Python. It's very easy, and it's not in the way, so to say. Okay, so checking back on my execution here again. So set the username and check back on our Python server, and we can see, hey, a request came in. So we have a GET request now here, and this proves that the application server interpreted the command I gave it to him, and then it basically did the requested something. Obviously, my Python server didn't respond with anything at all, but so we can we can make the machine do stuff and send it outwards for that matter. So, okay, with that being done, for talking 1 hour and 5 minutes straight, this is a very good point, I think, to do the very short break, and I will see you then in. I don't know, do you need 15 minutes break, or like is 10 minutes enough for you? I don't know if you want to leave early. Okay, then let's do like a 10 minutes break, and I will see you back then, hopefully. Thank you. Anyway, even if you haven't bought it, but for this boat, it is, I don't know, very floaty or something. So we can give a review, and let's submit it. And nice. So if we go back to the if you go back to WebSuite, we can see we have the message in here, and we have all the good stuff. So we can intercept every request, and we can also change the stuff around. And the next thing I would do is again use the request, send it to the repeater, and just play around with it a little bit. So because it's easier like this for me to just play around in this request in WebSuite, simply because I can resend it. I don't have to handle with the UI. So maybe let's change the text around a little bit, and maybe include something like some HTML tags, our beloved ones. Actually, let's not make alert one. Let's make let's make a console.log one, because in case this would be working, then we would be spammed with alerts, and this would be stored, so we don't want to like get an alert every time we reload the page, of course. So let's just send this, and it's saying response success. Have a look at the page again, reload the page, and if we open the review, we can see, okay, it's not working. So you might guess, okay, A, they have input encoding or output sanitization. So for some reason, my stuff is not working. However, if you look around a little bit more and, for example, see the search result and do the same here, like test, and for example, we add our mighty quote again and do something like this, we have no results found. And we can always have a look at the result like in the source code, not at the thing the browser shows us, by right-clicking, hitting inspect, and like really see, okay, what is shown there. And then in there we can find our result with test. We should be able to find it if we go down a little bit. This is the user ID. And there we can see, okay, it's in here and it's directly inserted. So maybe we try our result here again. So if I select our search bar again, use this script thing, the script tag, and use console.log one, and also a closing script tag for good measure, and do the same thing again, and check out the console. This should be working. Let's try again. Maybe I did a typo. Let's try it with a script tag. Okay, so for some reason it's not working right now, but this actually, as a pen tester, it's a very normal case. So let's just try to debug this and see what might be the cause for this. So if we go in here, we can see it's loading the page. And sorry, it's very small for me. I really have to climb into my laptop here. And you can see, so the tag itself, I hope you can see this a little bit, is inserted. And it should actually work. So yeah, let's try different methods and different tags, for example. So something I always like to use is an SVG tag, which is just another HTML tag. Let's try this one. And we can add an onload handler. So something, as soon as this tag is loaded, this will be executed. And for that, we use our mighty alert one again. And we can also add a source with an X. And this won't be loaded. So instead of onload, we can also use on arrow here. So as soon as the load fails, we can try to use this. And as we can see, something happened. Let's have a look again and see at the search results. And again, it's in here. Let me quickly look at this as well. Honestly, I'm a little bit baffled right now. Oh, thank you. Yeah, it's so small I can't see anything. But it's yeah, but the thing is the angle is so bad, so the big lights are very shiny. Okay, honestly, I'm not very sure why this is not working right now. So unfortunately, I have to spare you this one. This should be working. I'm not sure why it's not working right now. And I will also spare you like quite a bit of time in debugging this. However, when we did the nuclei and the SQL map, the Nmap scan earlier, we talked about something which was FTP. So have a look at this instead. So if we check out the FTP, and no, we don't want HTTPS. If we want to open the FTP directory, we can see different files in here, and we can see this is probably not something a developer wants to be public. So there are files in there that yeah, definitely should not be public. For example, there's an acquisitions.markdown. This document is confidential, do not distribute. So yeah, it's pretty obvious that this shouldn't be online. However, there's other stuff as well. For example, there's this coupons 2013, which I like coupons, so maybe have a look at this. And we can see, oh, we can only download Markdown and PDF files again. So what we can do now is play around with this a little bit more and see, okay, this check, this Markdown and PDF check, is this implemented correctly? So can we maybe bypass it? Can we get the file anyway? And let's just try around a little bit. For example, we could try something like we can add another directory in here, like just name it test, and then we add 2 dots in here. So what we are doing is going into some directory which doesn't exist, and then we go up again, and maybe this will bypass the test. And we can see, oh, why is it adding? So as we can see, this also doesn't work. So the browser removed it. And if we are not sure if the browser removed it, so if this was client side, or if this was browser side, we can easily go to burp suite again, get the request, and we can see in here, there's no test directory again. So send this to the repeater with the command R command again, and do this here again, because here nothing will stand in between. So there won't be any changes. So just add the test, ... and send it. And we can see it's still forbidden, it's still not working. So maybe we have to try something else. Another very common thing to test is to see if the determination of the file is actually done correctly. So what we can do is that we can try to add like an extension like which is, for example, a %00, and this is a null byte. So null bytes are handled very badly sometimes, not always, but from some applications they really don't like them. So maybe we can use this. And why is it redirecting me all the time now? And we can see, okay, a null byte is also not working for the moment. So what happens, or maybe this % sign, which, as you might know, in URL language is % language indicates that there is an URL encoded character coming next, and maybe this % sign itself got encoded. So if we really want to be sure that this % sign is sent as is, we can do this trick, and this is %24, and %24 is just an URL encoded % sign. So it's like an encoded % sign for good measure. So we can add it like here. Remove the S for HTTPS again, and it's still not working. But at the moment, we are adding this null byte at the end of the file name. But the security check was that only Markdown and PDF files should be allowed. So let's remove this here and move this after the Markdown and hope that the interpreter skips the detection afterwards. Okay, you seem baffled again. So for some reason, I don't know if I have changed anything in the shop right now. 25. It's 25, isn't it? Yeah, but isn't it 25? Oh, I did. It's 25, so 25 is correct. But that's a very good point. So we talked about encoders and decoders earlier. So burp suite very handily has a decoder on board. So we can easily enter a % sign here, and we can encode it as UL. And there we can see it's %25. Sorry if I mixed this up. Okay, so let me try around a little bit and see if we get this to work again. And let's. Yeah. since I'm not sure right now if I, for some reason, bricked my local shop right now, now if I will try to figure it out like for a very long time now, and there's just something wrong with my installation right now, I will actually skip this because it's very boring to look someone debug something, because you're doing this on a daily basis, I think. So sorry to say, but let's switch over to the next one because that's not a good example, I think. Okay, so okay, microphone switch on the fly. Okay, so let's imagine we have searched around a little bit, and we know that there. I mean, we are the developer, of course, we know, but we know that there's an administration panel as well. So for this application, it's simple. It's just administration, and we can see if we remove the S again, that there is a forbidden page. So we can't access this because even though we are logged in right now, we are user 1, we can't access the administration panel, which should be a good thing, I think. So we want to test if we are maybe able to get there. And for that, I will, the goal is to be logged in as the administrator in the first place. So we already know that the login request has an SQL injection, right? If you remember back, there's an SQL error in there. And if we know that we can do SQL stuff, we can also do some magic stuff. So we are logged out. And if we choose a very special username, so we are closing the SQL command with the apostrophe again, and then we are using a true statement, which is anything, for example, 1 equals 1, and then close the SQL query again. What will be there is like a select username where user equals test or 1 equals 1, which is always true. And the rest of the SQL query I will just cut off. So if I use any command now or any password now and log in, we can see without any correct password, without any correct username, we are logged in. And if we check our username now, or user profile now, we can see that we are the admin. Why? Because the SQL query just gave us the first user in the system, and there's quite a big chance that the first user might be the administrator of the application. With that in mind, let's go back to the shop and see if we can access the administrator panel again. And indeed, obviously, the administrator itself can access the administrator panel. And we also can see there are users in here, and we can look at details about them. And if we go back to, where is it? There, Burp Suite, we can also see like all the new requests coming in and all the new information and all the new details in here. Okay, so as we have seen, this is quite a bit of fiddling around and quite a bit of playing around with the different tools we have. I totally skipped like all the parts where you use like, okay, I found a very interesting path. I don't know, it's not documented in my application. It's not documented in my JSON. I don't know what this is in my Swagger API, for example. So let's use FUF, for example, to enumerate it. So see what kind of parameters are accepted and all of this stuff. You can obviously do this, but as a developer, most of the time you should know what your application is all about because you have the source code in the best place you wrote the application, so you should know what's going on there. But you can obviously do this, and there are many different use cases where you can use those tools to your advantage. And yeah, so fiddling around and using these tools, getting used to them is really useful, I think, and very gives you a competitive edge, as I said earlier, because most of the developers won't do this kind of stuff, and you are able to find your own vulnerabilities earlier. With that being said, I would change my screen again for a second and switch over to the presentation again. And let's have a quick recap of what we've seen today. So as I said, I really want to encourage developers to pick up these tools to find vulnerabilities earlier in the stage. As I said in the beginning, yesterday we learned how expensive it is to fix vulnerabilities in the later stage, 600 times more. So that's crazy. And also these tools can be integrated into workshops, in workflows and automations. So if you have a CI/CD running in the background, if you have some pipeline, GitLab pipelines, for example, you can put those tools in there. You can put, for example, nuclei in there and parse through the responses and see if there are any new findings. And if there are new findings, just look over them. It's very cheap to run them, but it can be very valuable. Finally, I want to promote a security-conscious development mindset. So security first, and security is within all of what we are doing. We have heard this very often in the last days, because in the end, the question is not if vulnerabilities will be found in your application, but only when they will be found. And with that, I'd like to thank all of you, and we have some time for a few questions if you would like. Thank you.